In this video, we are going to look at the equations of motion in physics, how to apply them in solving questions under motion. Alright, so let's begin with the first one. So basically there are four of them. The first one, we have v equals u plus at. We have the second one to be x equals ut plus half at square. We have the third one to be v square equals u square plus 2as. Alright, we have our x equals v plus u over 2 in brackets t. Alright, so here our v is our final velocity, our x is our distance. Let me write it here for you. Our v is final velocity. Alright, our u is initial velocity. Then we have the t is time, the x is distance. Alright, so these equations are very important in motion under physics. So most of the problems will be solving in motion. You will need the knowledge of these equations to solve them correct. Alright, so very important to get used to these formulas. Now note again that motion under gravity, this equation, the acceleration here we change to acceleration due to gravity. For instance, well, let me wipe this place. If you are dealing with motion under gravity, the v will be u plus gt. Now the x will be ut plus half gt square. The v square will equals u square plus 2gx, and in that order. This fourth one does not have acceleration in it. So when you are dealing with motion under gravity, the acceleration a will change to acceleration due to gravity g. Alright. Now this equation is when the motion is with gravity, is responding to gravity. When the motion is, for instance, when a body is falling down or when an object is thrown down, so is responding to gravity. But when an object is thrown up or something is moving up, is going against gravity, the equation of motion will be u minus gt, because this minus signifies that it's going against gravity. Same thing is applicable to ut minus half gt square, and v square equals u square minus 2gs. Alright, so take note of this variation. This one is responding to gravity, this one is going against gravity. Right, so let's look at a couple of problems here and solve them together so that you understand how to apply these equations to any question, any problem you are dealing with. Let's wipe this. Okay, so let's solve this problem together. It says a car moves from rest with acceleration 0.2 meter per second square. Find its velocity when it has moved a distance of 50 meters. Alright, so let's begin by getting our parameters. Okay, so in this question, our initial velocity will be, since it said the car moves from rest, right, from rest means that the initial velocity will be 0. Alright, since it's at rest, nothing is happening, so the initial velocity will be 0. Okay, then our a, we have our acceleration to be 0.2 meter per second square. Alright, then we don't have our v, final velocity, and this question does not have time. Does it have time? Find its velocity when it has moved a distance of, okay, you have distance to be 50 feet and does not have time. That means out of the three equations of motion, the one that will be suitable to solve this problem will be v square equals u square plus 2as. Alright, since we don't have time in this question, so when you substitute this value we have, you're going to have v square equals 0 square plus 2 times acceleration is 0.2 times 50. Alright, so v square equals 0 square is 0 plus, so let me multiply everything here with my calculator. Okay, so everything will give me 20. Alright, so we now have v square equals 20. So to make v the subject formula, you square both sides, so cancel the square root, so this square will cancel the square, therefore our v will be square root of 20, which will be, let me punch it. So we have it to be 4.47. We are talking about, okay, velocity meter per second. Alright, since if we leave it to the smart places, so this will be the answer to this question. Let's wipe this and look at a technical question. Okay, this question here says a ball is released from height of 20 meters. Calculate I the time it takes to fall. I the velocity with which it hits the ground. Alright, so since the ball is released from a height, that means this is a motion under gravity. Let's bring our parameters. For in this case, we have our x distance to be 20 meters, and we are looking for time first. We don't know time, and we don't know. Okay, we have our initial velocity is going to be 0, so u will be 0. Let me explain. Okay, let's say this is a wall, this is a tall wall, and somebody is standing here and releases a ball. Alright, so somebody release the ball from this height. So initially the ball will attain a velocity of initial velocity of 0, alright, before it starts making movement or falling. Hope you understand. So whereas the final velocity is unknown, so the velocity it will take from here till when it hits the ground here will be the final velocity. This one is our initial velocity, u, which is 0. So having gotten these parameters, now which equation are we going to apply? Remember, this is a motion under gravity, so we have these terms, we have time, we have u, don't have v. That means we're going to apply s equals ut plus, okay, is responding to gravity because it's falling, right? Plus half gt square. Alright, since the ball is falling, it's not going up, it's going down, it's responding to gravity. Now when you substitute this value, we're going to have our x distance is 20 equals 0 times t plus half. That means acceleration due to gravity, g is constant, which is 10 meters per second square. Alright, so when you impute it, you're going to have half times 10 times t square. So when you simplify this, you're going to have 20 equals, everything here will give you 0 plus 10 t square. Alright, so when you simplify it more, if you cross multiply, you're going to have 20 times 2, 40 equals 10 t square. So divide both sides by 10. This will cancel this. 10 t here 4. Then have t square equals 4. To make t the solid formula, you square both sides. This square I can't describe. Therefore, root of 4 is to that our time t equals to 2 seconds. Alright, so this will be the time. Now let's wipe this and solve for the second way, the velocity with which it hits the ground. Okay, so we now know our t is 2 seconds. Now to get the v, final velocity, we can either use v equals to u plus gt, alright, or we can use x equals v plus u over 2 times time. Anyone will work, but let's use this one first. So to find v will be initial velocity is 0 plus our g is 10, then times our time is 2. Therefore v will be, final velocity will be 20 meters per second. Whereas if you use this one, so to our x is 20 equals our v is unknown plus u is 0, alright, over 2. The time is 2. Alright, so when you simplify this, you are going to have 20 equals 2v, 2 times 0 is 6 give you 0, so it's just nothing is there, alright, over 2. You can't multiply, so you're going to have 40 equals 2v. To make v the solid formula, divide both sides by 2. Alright, therefore 40 divided to 20, therefore v equals 20 meter per second under velocity. So anyway we work, guys. Right, so it's as simple as that. Now let's solve one more example under this before I call it a class. Okay, look at this question. It says a ball is thrown up vertically with a velocity of 40 meters per second. Calculate A, the maximum height, B, the time to reach maximum height. Alright, solution. Remember, this is a motion under gravity, right? Yeah, because look at the ball is thrown up. Now it's going against gravity because it's not falling, it's going up. Remember what I told initially when I was starting this video. Okay, now since it's going against gravity, that means our g will be negative. Alright, so let's write that our parameters. Our initial velocity is 40 meters per second. Alright, then our g will be 10 meters per second square. Alright, remember g will be negative, not be positive. Whereas our, what else do we have? We're looking for maximum height. That's, we're looking for x is unknown. Alright, then our v will be 0. Let me show you. Let me say this is a wall and this is the ground. So when you throw up an object, let's say a ball, this is a ball. Alright, you threw up a ball. Now they say that this question says that the velocity you use to throw up the ball vertically is 40 meters per second. Okay, now the final velocity v will be the velocity at this maximum height. Let's assume this is the maximum height this ball reached when you threw it up. Alright, now this will be the maximum height. This will be final velocity 0 because the ball will get to this point before it starts falling back again, before it starts responding to gravity. But this time it's going against gravity, so it will reach this point. This point is reached before it began to fall back. This is the final velocity, but before it started to fall back. Alright, so the v will be 0. So let's look at the equation of motion we're going to apply to solve this. To get this distance, the maximum height, that distance, so it's going to be, we use v square cos u square. It's not plus, it's going to be minus because we're going against gravity, minus 2gx. Alright, so our final velocity is 0. Initial velocity is 40 square minus 2 times, alright, 10 times x. Okay, so when you substitute this in this, when you simplify this the more, you're going to have 0 equals 40 square will give us 1600 minus 20x. So to make x, which is the distance, is the formula. This 1600 equals over this, what is going to be minus 1600 equals minus 20x. Right, so you divide both sides by minus 20. So this will cancel the dynamic. Therefore, our x will be, when this divide this, we're going to have 80. Our x will be 80 meters. Alright, so this will be the distance, the maximum height distance. Right, now to calculate the time, very simple. Let's wipe this. So remember, now our x will be 80 meters. To calculate the time, we can use v equals to u plus, v equals u minus gt. Okay, so when you substitute, you're going to have our v is 0, 0 equals 40, alright, minus g is 10, alright, t. Now, we make t the solid formula. This 40 equals to b minus 40 equals minus 10t. Divide both sides by minus 10, minus 10. Therefore, our t will be 4 seconds. So this will be the answer for this question. Now, this particular question can also be solved using projectile formula to solve it, because it's talking about maximum height and time to reach maximum height. So let's solve it projectile. Alright, let me show you how you can also do the projectile. Alright, in projectile, to calculate maximum height, you use square sine square theta over 2g. So our u is 40. That's 40 square. Then this sine squared, that means you should times sine theta into 2 times. That you do sine theta times sine theta, that's multiplication into 2 times. Alright, now our theta will be 90 degrees. Let me show you, because this is the wall. When you throw up a ball from up, this is the ground, and making a connection with the ground, so you are forming angle 90 degrees. So theta will be 90. Alright, so it will be sine 90 degree times sine 90 degrees, right, over 2 times 10. Because acceleration due to gravity, g is constant, p is 10. So when you simplify this, sine 90 is 1. This is the same thing as 40 square, which will give us 1600 over 2 times 10, give it 20. So we cancel this. 2 cancel itself, 1, 2 cancel, you're going to get 80. So you can see that you still get the same value for maximum height to be 80 meter. Alright, now the same thing is applicable to time to reach maximum height, which is, let me write this. Time to reach maximum height in projectile is calculated using u sine theta over g. Alright, so our u is 40, and 40 times sine 90 degree over 10. Alright, so sine 90 is 1, so we're going to have 40 over 10. So you still get back to 4 seconds. So either one will work for this particular question. Alright, so this is basically how you can apply the equations of motion to problems involving motion and solve them. Alright, so guys, with this we have come to the end of the class. I hope you learned something interesting. If you're new to the channel, show you the subscribe button to subscribe to the channel for more videos. Like, share, and comment on this video. Tell me how you feel, what you have learned. If you seem to have any specific questions, feel free to leave a question in the comment section below, and we'll share a response. That's it for this slide, guys. Thanks for watching.